Hi all. Okay, we'll move ahead with the next topic, that is sigaction API. Okay, so this is sigaction API is a almost replacement for signal API. Okay, but these are referred in latest Unix and POSIX systems. Okay, so this is almost same as that of signal. Okay, so just we'll have a look at what signal we studied. Okay, so whenever we had signal like this, okay, so here we used to give one signal number, then this is the handler we used to give it, so which handler you have to refer it. So here also same thing, so just we have almost same kind of thing. It's a signal number, and here one structure we are giving it. What the structure contains is, this is nothing but here you have the handler and masking and some flags. Okay, so those all things are together, it's binded and it's formed as a structure variable. Okay, so the structure variable will pass it, and this along with this one here we are saying as a old action. Okay, so here this is new one, whatever we want to do it as a old action. So something is already it's there, so that we can replace it. Okay, so both that APIs, that is signal and seek action. Okay, so pass back the previous signal handling method for a given signal. Okay, so nothing but whenever you will call this one, so always those sig action and signal both will pass back the previous whatever handler was there, that to the that whichever process calling this sig action. Okay, so for that it will pass the handler. Okay, so here it will pass it here. Okay, there's an old action, it will pass it. Okay, so here we'll just will see, so what is that structure contain. Okay, so what's the structure, so how it's defined. Okay, so here it's a stuck sig action, so in this we have the signal handler. Okay, so here is the parameter. Okay, so here normally we will receive the integer parameter. Okay, so or any handler, there is a whatever user given handler will be there, along with that sig ing ign. Okay, so that is something but ignore, and here default action. Okay, so DFL, so default action. So these two signal handlers you can give it, or whatever user defined that signal handler you can give it. Okay, here I think I missed typing int. Okay, so integer parameter it has to take. So always it will take the integer parameter, that is a signal number. So whatever will pass this number, that will be considered as the integer parameter for that signal handler. Okay, so along with that you can give this some additional signal, so which one you can block it. Okay, so this one already we have shared, sig set underscore t. So here masking kind of things will do it. So whichever you want to block, that also you can give it. Then sig flag also you can give it. So that is nothing but some signals options, so you can use it. Okay, so for that we'll see one example. So here this is one example. So and this structure is defined in signal.h header file. Okay, so here, so C++ file, C++ code we have written. So what this content is, so one call me function. Okay, so that is nothing but whatever handler we are going to write it. Okay, so whenever main will start, so that time just what we are doing, sig set underscore t. So there is a masking one variable we are creating it. Then whatever the structure is there, for this structure we are going to create two things, two variables. Okay, that is one is action, one is old underscore action. So two variables we are going to create it. And this signal mask, so initially we'll set it to the empty. Okay, that's whatever by default is there. So this is sig empty set, we'll call it. So automatically whatever by default things are there, that will set it to zeros. That is what we are saying is a reset it. Okay, so set it as empty completely. Okay, so after that what we are doing is sig add set. Okay, so here some signals were adding it. So that is a here whatever variable is there, for that variable sig turn. Okay, so termination the signal that we are adding it, and we are checking it, is it a -1. Okay, so this function we are calling it, so for addition purpose signal, this signal we are adding it. So we are checking, is it a -1. If it is a -1 means this function is failed to execute it, so no need to execute second one. Okay, so if when it will become as a true, so this is our part. Okay, so this entire thing is a true means no need to execute this one, because this if condition is already true. Okay, so just signal masking is failed, that error will display and will come out. Okay, so if it is uh, not minus one means successfully this add set is executed. Okay, then that time it will return as a zero value. Whenever it will execute successfully, it will return a zero. So that time we are going for our part. Then we are executing one more thing, that is sig proc process mask. Okay, so here what we are doing is, here we are setting the set mask. Okay, signal set mask command we are giving it. So which this is the variable. Okay, so then old one is zero. Okay, we are not worried about old one. Just in this we are going to set it. Okay, so sig mask we are doing it, sig process mask we are doing it. So this will set the signal for the this process. Okay, so now again we are checking it for minus one. If it is a minus one means execution of this process function is failed. Okay, otherwise this is successful means zero it will come. So now we will come here sig empty set. Okay, so action dot sa underscore mask. Okay, so if you saw here, so in this structure we have one data type. Okay, that is sig set underscore sa mask. So previously we used to use this for another differently. Now in this structure only we have that one. Okay, so in this structure that we are, what we are doing is we are setting it to empty. Okay, so here also again we are adding it, that is a segmentation related signal we are adding it. Okay, so in this sig add, so whatever we did it here, same thing. Okay, sig add set we are adding it, so signal we are adding it, then we are giving the handler. Okay, that handler is call me. Okay, so here this is a call me handler we return. This will take the signal number whatever we are getting it. Okay, and in this handler what we are doing is just we are printing it catch signal. So whatever handler is there, so when it will come, so whichever signal it received, that signal it will print it. Okay, then flags we don't want to set anything, so just we're giving this zero. So now we're giving this one, so old one, so old action we don't want to do anything, just we want to receive it, so we'll receive it in this one. Okay, so and new one, so already we modified, so that is sig action. So we start, initially we made this one as a flag as a empty. Okay, so then we added this segmentation flag. Okay, then handler also we given, that is a call me function, whatever is address is there, this is a call me function, that address we are given. Okay, then flag we set it to zero. So then we will call it a sig action. Okay, so it's like system whatever signal whatever we used to call it, same thing. Okay, so here we are giving as a, this is the signal in it. So here this is whenever it will come interrupt, so by default it has to terminate it. Okay, so for that signal, so here we are giving the this handler also, this masking also. Okay, and this is a flag also, all three we are giving it. So then old we are giving as a nothing, so this is a empty one. Empty one because we created the variable but we are not modified anything, so it's a empty. Okay, so that we are giving it. So if it is minus one means so execution is failed, otherwise it will go what we are doing is we're just we're pausing it. So this process whatever we are executing this one, so it's paused here. Okay, so waiting for a signal interruption. Okay, so here we enable this one signal interruption for this process. So whenever it will be interrupted, so corresponding whatever things are there in this action part, it will execute it. So that is something what in this action, this is structure variable, we have the handler and we have the masking also. Okay, so this masking also we have it, so that part it will execute it. So just we'll see the output. Suppose we have compiled as a written that saved that file as a this sigaction.c. Okay, so we are compiling as a cc, that's in C++ code actually. Okay, so you C++ compiler. Okay, cc file name minus o sig action. Okay, so sig action we kept it the our output, so our output is redirected to sig action. So sig action we are just we are giving as a percent, this is nothing but we are saying as a run in this process in backend. Okay, so this will give the process id. So now here we are calling the kill. Okay, kill api. So here we are giving the whichever signal you want to give, then to which process. Okay, so process id we got here, so that process id we are giving it. So here signal. Okay, so just it's printing, so what signal we got it. So int value, there is a signal catch. Okay, so here if you saw here catch signal, just number we are printing it. So whenever we executed this one, so for that we got this one as a 2. Okay, so for this one, this int signal we got as a 2. Then action signal. So then after this just we are printing, so what is that argument we got it, first argument, that is a by default name will be there. So this is the name, so whatever we executed file name, so this is the name that is there. So argument 0. Okay, Okay, so first argument, zeroth argument, so that we are printing it, then just we are saying the exits. Okay, so just exits, it's printing it, then we will come out of that processor. So whatever backend it was running it, that is also closed. So we are saying as a here as a one done execution. It's nothing but file name, just it's printing it. So this is a signal action, how it will perform it. Okay, and now we'll see next one is kill. Okay, so here the skill is actually a one API also, command also. Okay, so if you saw here, this is we are using as a kill as a command. Okay, so it's a command, and in applications you can use this one as a like API also. Okay, so now we'll see what is the API. Okay, so this is the kill command. So in that we are passing the some arguments. Okay, so normally ls command, how it will use as a minus l argument. So like that we are passing it here the arguments, the signal, then is a process ID you are sending it. So now we'll see so how this kill API is there. Okay, so what kill API will do is this nothing but a process can send a signal to a related process via kill API. Okay, so whichever process you want to send a signal, that you can send it. For that you can send it. So here, so kill, just we are calling it. So to whom you want to send it, then which signal you want to send it. So that will give it into the API. So here command is indirectly same thing. So here kill is there. Okay, it's a command. Okay, so which signal you want to send it, which process you want to send it. So it's from the kernel, by default you are sending it. So here if I call this one in my application, means that running application process will send it to the different process. So that is nothing but whichever process ID you are giving it. Okay, so whichever process ID I can give. Okay, so here normally you can give the any positive value. Here process ID we can give normally a positive value. So if I given as a that positive value, so for that process this signal will be sent. So whatever signal number you are giving here, signal, okay, so that will be sent. Okay, if I given as a 0, so what will happen is a signal num to all the process whose process group ID is same, for that it will send it. So whenever I will give 0, signal will be sent to all the processes whose group IDs are same. So whichever process is calling this one kill, so that process and group ID whatever is there, so which, all the processes which have the same group ID, it will send it to that. Okay, then here if I send as a -1, so it will send to all the processes whose real user ID is same as that of the effective user ID of the calling process. So it means whichever application is calling this one, for that effective ID whatever will be there, so that effective ID should be same as that of other processes. Okay, so that is a real user ID. So if it is same, means it will send to all those processes, it will send it. Okay, so this is what three different kind of values we can use. So positive value particular one process, 0 all processes for a same group, -1 all the processes of a same effective ID. Okay, so that you can send it. So this signal you can send it. Okay, so just we'll see one example. Okay, so here we are using the actual kill. Okay, so how we will use it. So here from main, what we are doing is just we are receiving argument. This is a command line argument we are receiving from the user. Okay, so whatever he will run it, that command line argument, just we are receiving it. Now here PID one variable we created, then sig one variable created is the integer type. Okay, then sig term. Okay, so the sig term signal we are using it. Now we are checking is it a signal arguments are 3. Okay, so if it is argument is 3, means just now what we are doing is yes scanf. Okay, so this is the first argument we are going to read. Zeroth argument will be always file name. Okay, so first argument after that, after file name whatever is given, so that we are going to read it. Okay, so now that argument, okay, so whatever we read it, so that we will store in this sig. Okay, so it's sig whatever is there, that we are writing it f scanf. Okay, so that's the signal number. So first argument always is, because if you saw here command how you execute it. Okay, so here, so kill, then this is the signal ID will be there, then this is the process. Okay, so here in this one how it is implemented is just first argument we are reading it, 0th argument will be the file name, that is a whichever file you are executing, then this after that there's a signal number will be there. So normally we will use a kill space, then signal number space, then PID. So here this is whatever signal is given, that we are taking it. So here this signal will be read. Okay, so if it is executed, this one is a not equal to minus, not equal to 0. Okay, so not equal to 0 means it's a failure. Okay, so if it is failure, just we are ending as a invalid number is given. Okay, then if it is not failed, has successfully executed other than 0. So so here what we are doing is argument whatever vector is there that you are incrementing. Okay, then number of counts we are decrementing. So number of counts initially it was 3, so that is nothing but file name, that is a kill file name, then process signal id, then process id. Okay, so three things were there. So if it is not 3, so uh, if it is equal to 3, just we are reading the argument. If it is not 3, so some task we are performing it. Here minus minus whatever we did, same thing here it will reflect it. So argument minus minus will do, and will check it is it greater than 0 or not. Okay, so here if it is greater than 0, until and unless it is greater than 0 means number of different processes you can give. So uh, kill space, okay, signal you can give, then processes you can give it. So n number of processes you can give it. So until and unless all the processes get over, so we'll do it. This is the while loop. Okay, so I can give as a kill sig terminal process 100, 101, 102, 103, like that I can give it. So whichever process number will give for that, those all processes it has to execute. So until and unless it comes greater than 0, is almost equal to 0, so we'll execute it for all the processes. Okay, so here what we are doing is we are reading the PID. Okay, so fscanf, there's a from the command line whatever we got it. So argument vector, that is by default it was from the 0 will be there, so we incremented, this came to 1. Now again we are incrementing here, so it came to 2. So there's nothing but 0th argument is a file name, first argument is the signal, second one is the actually your process id. So process id we are reading it. Okay, so it's a reading as a integer type, and we are keeping it here. Okay, so this will read it, so continuously will read it, and we are calling the internal signal, sorry, kill API. Okay, so kill API is nothing but whatever PID we read it, we are sending the signal. So whatever signal we received here, that one we are sending it. So if it is -1 means the execution is failed. Otherwise, continuously we'll perform this task. What is the task is here in while loop? How many processes are there? For all the processes we are sending this signal. So only once you can give the signal. So remaining all n number of processes you can give it. Okay. So next alarm. Okay. Alarm we will study in next class.